Okay, so here's the last concept of this section. I know this was a big one, right? We've got this, so we're so good. Okay, so here's the last concept. For a fixed P, pardon me, as the number of trials increases, so number of trials, right? So my quantity is increasing, the probability distribution becomes bell-shaped. Well, thank you, Captain Obvious. I mean, how many times have we heard that before? The law of large numbers. The more numbers you put in there, the more accurate, the more normal the data gets. Ta-da! Same thing is still happening here, right? As n increases, a rule of thumb is this formula. The probability distribution will be bell-shaped. This is your proof, if you will. This is the formula that will always happen here to determine if this is bell-shaped. That's the key. All right? If those n times p times 1 minus p is greater than or equal to 10, boom, then I know I can work with it being bell-shaped. Okay, so let's try this on. The CTIA, well, guess what? It's the exact same thing. 72% of adult Americans would rather give up chocolate than their cell phone. In a random sample of 300 adult Americans, 230 indicated they would rather give up chocolate than their cell phone. Is this unusual? So we're trying to figure out if this is unusual. So let's see if this is bell-shaped, because that's what we want to look at, right? And then how do I know if something's unusual? What does that mean? Yep, that it's less than 0.05. Good. Okay, good. So we're bringing that back now, right? We had that previously, and we're bringing that back to what we were looking at. So P is still equal to a 0.72. My N is still equal to 300 that we're working at. So then that's what we're plugging in. NP, 1 minus P, has to be greater than or equal to 10. So let's plug this in. My N is 300. My P is, I lost it already, 0.72. 1 minus 0.72 has to be greater than or equal to 10. And then what do you get? I get 60.48. Is that what you get also? Is that greater than or equal to 10? Yup. So this means, so we know the data is approximately bell-shaped. If I know something that's bell-shaped, what do we know about it? Empirical rule. Oh my gosh, you mean we're using something that we currently learned in the previous lesson today? Yes! Now we use empirical rule. And that's why we learned those previously. Remember, with the empirical rule, you have your mean. 1 standard deviation away is that 68%. 2 standard deviations away is the 95%. Why is 95% important on this one? Those 2 standard deviations away. Because we want to know about unusual. Oh, sweet, right? Yes. So plus or minus 2 standard deviations. 2 plus or minus 2 standard deviations. That's going to be my 95% that we've talked about. All right, so let's figure it out. So we've got our mean that we have. Mean, nope, I don't want to write that. I want to write this. Mean is plus or minus 2 standard deviations, and that's what we're trying to look at. If I have my mean plus 2 standard deviations, and then I also want to look at what's happening with my mean minus 2 standard deviations. Now, what did we figure out was our mean? And here it is, right? Our mean is 216. We already did that because that was on my previous problem. So our mean is 216. I should write it over here. Mean is 216. So my standard deviation, we had that on the other page too. What did we get for that? 7.8. Standard deviation is 7.8. So I have my, oh, dang it, you guys, you're probably yelling at me because you're so smart. I appreciate you so much. No, that's the mean. That's the mean. You're right. I'm wrong. Good job. Good job. So this is 216 plus 2 times 7.8 and 216 minus 2 times 7.8. Mm-hmm. So 2 standard deviations up, it'll be 231. Oops, I'm going to put it down here. 231.6. Two standard deviations down is 200.4, right? So then I know that I'm within 95% of my data. So 95% of my data is going to go from 200.4 to 231.6. That's 95% of my data. Here's my question. Is 230 part of that? Yes. Do you see that? So 230, does that fit in my interval? Yes, so it's not above or below, right? So it's within that interval, that 95%. So it is not unusual. Oops, I wanted to change my color. So 230 is not unusual because it's within that interval. Nice, right? Yeah, so we're bringing stuff back, right? We're bringing back mean. Expected value is the same thing. Standard deviation we're working with is something unusual. Empirical rule. That's the beauty of it, right? You learned something previously and then we just keep putting it together. This is awesome.